Hi everyone, Mrs. Ailstack here. So, as we talked about in class today, we didn't get a chance to finish everything, but I'm following up with the video because I don't want our class session to be rushed, and you guys did such a good job participating and asking some really good questions. So, we're going to pick up right where the lesson left off, and hopefully, this will help, round out your understanding of the coordinate plane and help better, make sure that you are prepared for this week's assignments. All right. First off, where we left off is we were talking about distance, and we were working with finding distance from both the graph method or using the subtraction method. So we'll go through a couple more examples on that because I know we did some, but we kind of ended, and I was glitching out a lot when we were having the discussion on what to do with the negatives. So if you want to use the graph method, what you'll simply do is graph your 2 points on the number line. So our first one here is 9, -7. The first number is our x value. The second is our y. So we start at the origin, the center, and we'll go over +9 on our x, and then down to -7 on our y. And right here is that point. And then our second point, we'll change color so you can tell the difference, is at +9, +4. So once again, we start at the center, the origin, and we go over 9 on our x. And then because it's a +4, we'll go up 4 on our y. Now we're being asked to find the distance. If we recall from first semester, another, thing that we work with that involves distance is absolute value, because absolute value is distance. It's saying it doesn't matter that one of these is located at a +4 on the y and one's located at a -7. We want to know how far apart they are. What is the distance? So our answer will be a positive value. If you have a graph, you can honestly simply just count. So we can see that they're 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units away. So when I did this by graphing, they're 11 spaces away. That's the distance. But if you don't have a graph or you don't feel like drawing and making a graph, you can also do it as what's called algebraically. So just do it without the graph. So when we're trying to find distance with what we're working on this year in 6 Advance, we're only ever going to be finding the distance between 2 points that make a straight line. Like if we look at this example here, we can see it makes a vertical line. They're on that same x value. They're just someplace different on the y. Or it could be horizontal. So we're only going to be finding distance between horizontal or vertical lines this year. So with that being said, if we identify that the x value is the same, that didn't change at all. So we don't really need the distance there because that's the same number. What we want to focus on if we're not using a graph is whatever values are different. And in this case, it's our y's. We have a -7 and a 4. There's a couple different ways that you could show your work. And this is where I started glitching out in class, so I'll try to show you a variety so you can see what works for you. One way is right off the bat, take the absolute value, because you know that if we're talking about distance, it doesn't matter if the number is at a positive or a negative. So we could just right off the bat take the absolute value and turn that into a +7 and add that to our 4, and we get the answer of 11. They are 11 units away. If you didn't want to deal with the absolute value, then another way you could do it is you can take your positive number and subtract from it your negative number. Because if you're trying to find the distance, you could think, oh, well, that's the difference. I need to subtract. Well, when we subtract a negative number, those cancel each other out, and it really becomes 4 + 7, which is 11. Or a third way you could choose to do your work, running out of colors here, is you could say, well, I'm going to take -7 and subtract the 4. I want to find the distance. That makes me think of subtraction. You can do so. That is another way of saying -7 plus -4, which would be -11. But when you get to the end, you'd say, well, I'm talking about distance. I need to take the absolute value, and that would be a +11. So even though I showed you 3 different ways, I personally think most students like this one the best. So that's the way on the next example. We're going to do it. And, if you like one of the other 2 ways, that's fine. We all think differently. There's 3, if you include the graph, 4 different ways to do this, and you all get the same answer. But I'm going to focus on this first one I did in pink because I think it's a little bit easier. And I think there's less room for error when you're dealing with the subtractions and the negatives. So that's what we'll do on this next example here in a moment. All right, let's try one more of these distance questions. I think my video is covering part of the question, so I've kind of rewritten it down below, but we want to find the distance between the points -2, 4 and +8, 4. So if we do this graphing, and whether you choose to do it this way or not, it's great practice. So that's why I like continuing to go through that. Our first point is we'd start at the origin and it's -2. So we'd go left 2 on the X, up 4 on the Y. That's our first point there. Now for our second one, it's at 8, 4. So we would go over 8 on our X, up 4 on our Y, and there they are. And like I said earlier, last time we had 2 points that kind of made a vertical line. We can also have horizontal ones because they are ones that right now we can tell the distance between by just simply counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are 10 units apart. That is the distance between them. Now, if we choose to do it without the graph, well, when we look at our points here, we don't really need to worry about that y value because it's a 4. That's what stayed the same. That's what's making it a nice straight line. What we want to focus on to find that distance are the x values in this case. You always want to look at those numbers that are different. That means they're spread apart. So we want to find what's the difference between the two. What's the distance? So because we're dealing with distance, that makes us think of absolute value. So if one of your numbers is negative, just go ahead and take the absolute value of it. So the absolute value of -2 is a +2. And then if we add our 8, we get the answer of 10. And look at that, same thing that we got when we graphed it. Okay, excellent job. All right, let's take it up a little notch, try this out here. So if we have point G, which is not graphed, but it says G is located at 3, -1. So then which point is 5 units away from G? All right, well, first thing we want to do is we better graph that point, 3, -1, over 3, down -1. Right here is point G. So take a moment. I'll give you a few seconds. You can pause the video if you need more time. But which one of these answers, A, B, C, or D, is 5 units away from G? All right, it might take you a minute longer to get the answer. No worries. Pause the video if you need to still figure it out. If you have your answer, let's go over it. So when I look at point G here, the first thing I notice is it can't be C because as we discussed earlier, we're only dealing with vertical and horizontal lines this year. And if I were to connect C and G, that would be a diagonal. So it can't be point C. That's definitely not it. But B and A, would make a nice horizontal line with G, and then D would make a vertical line. So I'm just going to go ahead and count. Since I have a graph available, that's the method I'm going to use. So we are 1, 2, 3, 4 units away from D. I needed it to be 5. D's not it. All right. Let's go from G to A, and if it works, great. If not, I'll keep going and hope it's B. So we're 1, 2, 3, 4 units for A, but looky there, 5 units brings us to point B. So point B is 5 units away from G. That is our answer. All right, we have two more questions before we get to the next topic. And we're going to kind of bring that reflection and the distance together, which is great because, I see by some of my emails that I've gotten, a few of you are like, I'd like a little bit more practice with reflection. And we had planned on doing a bit more practice and circling back to it, just ran out of time. So here we are told that point C is located at 6, -4, and we want to plot the reflection over the y-axis and label it as point D. Find the distance between C and D. So we'll do this both with a graph and without a graph for that reflection piece so we can get some more practice on how to do both. So we're told, if we use our graph here initially, that C is located at 6, -4. Notice that our graph is skip counting. We're counting by twos, but that's okay. We can do that. So we go over 6. Oh, I almost went up 4, but it's 6, -4. So I got to go down 4. So right here is point C. Now we are being told that it is reflected across the y-axis here, the y-axis. So if I have a graph, just to make sure I don't make a mistake, I always like to highlight it or draw a line through it if I'm able to, because this is our y-axis. So that means we're reflecting it over that. So it's going to be a left and right reflection. It's kind of like if you take, a piece of paper and you fold it in half, you'd have, and you draw a little heart on it, or if you were to, actually, this only works if you cut it. Don't have scissors by me. But if we had a heart, let me make this example better. All right. So if we had a piece of paper here and I drew a heart on it, and then I fold this paper in half, each side matches. It's like it's a reflection across that y-axis where it's symmetrical, the same on both sides. So when we reflect something across the y-axis, we're flipping it, we're reflecting it over the y. And then after we finish this, we'll do an example with the x-axis. So a couple ways that we can do this. If you have a graph and you recognize that I'm flipping it over the y-axis, that's the reflection point, it's going to be symmetrical on both sides. You can honestly count again. We can look at this and say, well, if I choose to figure this out by counting, I'm 1, 2, 3 spaces away from my y-axis. So if it's a perfect reflection, it's going to be 1, 2, 3 spaces away on the other side. And we were told to label that as point D. So that's how you could use the graph to figure it out. But if you don't have a graph, there's a rule that works. If we look at this, let's identify our ordered pairs here and see if you can figure out the rule. So this is located at 6, -4, and our reflection over the y-axis of D is located at -6, -4. What do you notice about those points? I notice that it was reflected over the y-axis and the y value is the same. It's a -4 both times. However, once I did that reflection, look at your x value. It was a +6, but then it became a -6. So that's our rule, and this is in your notes that was published for today, that if you reflect something over the x or the y-axis, there's a rule that you can use. So specifically for this one, if it's reflected over the y-axis, then your y value stays the same and your x value has the opposite sign. So if you wanted to solve this without a graph and you notice that your point is 6, -4 and it's reflected across the y-axis, that would tell you that the y value stays the same and the x value becomes the opposite. So that +6 becomes a -6. Now that we've done that, let's find our distance. Well, if we do the counting method, that's kind of already done here for us. We're 1, 2, 3, 4, 5, 6 spaces away. However, my graph counted by twos. So I better recount that and make sure I count by twos because this graph isn't going by ones. So we're 2, 4, 6, 8, 10, 12 spaces away. If we did this by not using a graph instead, well, when I look at my 2 points, the x value is what's different. We have a -6 and a +6. The absolute value of -6 is +6. 6 plus 6 is 12. So that matches the answer. They're 12 units away. All right, let's clear this and do the exact same problem, only let's reflect it across the x-axis instead. So if we graph our point C here at +6, -4, but this time we're going to reflect it across the x-axis. Well, once again, if you're able to, I like to highlight that x-axis to make it a bit more obvious. And if we're flipping it across the x-axis, we got to flip it over that. So it's going to go from underneath it to above it. So if you choose to do that reflection by using a graph, I can see that we're 1, 2 spaces away from the x-axis. So I would need to be 1, 2 spaces away on the other side, landing us right here for point D, which is located at 6, 4. What do you notice about the pattern there? Well, when it's reflected across the y-axis, the y stays the same. But when we reflect it across the x-axis, what stays the same this time? Yeah, the x stayed the same, but our y became the opposite. We went from a -4 to a +4. So if you were doing this without a graph and you had your problem and you saw that your point was located at 6, -4 and reflected across the x-axis, that would say, all right, if it's reflected across the x, my x stays the same, my y becomes the opposite. So that -4 becomes a +4. If we look at our distance here, well, if we use our graph, remember it's counting by twos, so we're 2, 4, 6, 8 away. If we do that without using the graph, I notice that my x's are the same, the y's are different. So those are the numbers that I need to use to find the distance between. We have a negative, so let's take the absolute value of that, and we get that same answer of 8. They're 8 units away. All right, let's look at one more here real quick before we get into the last part of our lesson. So how would you describe point C? Pause the video if you need to, take a moment to think. All right, well, there's 2 different ways that we can describe point C. The first thing that I notice is C and D are an equal distance apart from our y-axis. So one way is C is reflected with D across that y-axis. So C and D are a reflection across the y-axis. But I also notice that if we look between C and B, they're an equal distance away. So C and B are a reflection across the x-axis. All right, here is the last part of our lesson, is finding area and perimeter on the coordinate plane. I think you guys will really like this part because all it is it's taking what you learned in fourth or fifth grade about area and perimeter of squares and rectangles and applying it to our coordinate plane, because that's the only shapes that we're going to work with this year on the coordinate plane is squares and rectangles and finding their area and perimeter. So we're being asked to graph the square STUV and find both the area and the perimeter. So the first thing we need to do is graph those points so that way we can have a visual and we can actually see what our square looks like, and then we'll be able to calculate it. So our first point here is S, which is located at 9, -6. Then we have T, which is at 9, -7. Well, that's not very far away. Next up is U at 10, -7. And last but not least, we have V at 10, -6. What shape does that create? Creates a teeny tiny square, doesn't it? So if we look at this, whether we're finding area or perimeter, and we need to do both, we need the length and the width of our square. Well, I can see here that the distance between these points is 1 unit. So we have a length of 1 and a width of 1. So our length is 1 and our width is 1. So the formula to find the area of a square is length times width. So we will simply take 1 times 1, and that would give us an area of 1 unit squared. Oh, do you remember how to find the perimeter? Well, the perimeter also requires us to have the length and the width, which is 1 and 1. Two ways we can do it. One, you can just add up all the sides because perimeter, remember, is measuring the outside of the shape. So you could literally just add it up and say, well, this is 1, this is 1, this is 1, this is 1. Add all those up, we get 4. Easy enough to do. If you have a bigger shape, the formula may be helpful. You may not want to do so much counting, so I will show you that as well. So remember that your formula for perimeter is 2 times the length plus 2 times the width. The reason for that is we have 2 sides across from each other that are a length of 1, and then we have our other 2 sides across from each other that would be our width of 1. So perimeter is equal to 2 times our length of 1 plus 2 times our width of 1. Now we just use order of operations to solve. Multiplication comes before addition. So we'd have 2 plus 2, which gives us a perimeter of 4 units. The nice thing is with this graph, you can choose to use the graph and, count the lines, count the boxes, or you can just get the length and the width only from the graph and use your formulas to solve, kind of up to you. All right, let's do one final example and then we will have finished the lesson and we'll close out. All right, let's try this same type of problem out just with a rectangle. Do it one more time. Always good to see a couple examples. So first steps, we need to actually graph this rectangle. So we'll be able to find the distance between the 2 points, be able to see what our length and width are. So first off, we have U at -2, -5, left -2 on the X, down -5 on the Y. And then we have V at -2, -10. So left -2 on the X, down to -10 on the Y. I know the -10 isn't labeled. That's just kind of out of space, but we can tell that it's counting by ones. So obviously -10 comes after -9. It would be that next box down. All right. W here is at 10, -10. So we're over at +10, way down here at -10. And then X is at 10, -5. All right, we have a much bigger one here. We had a teeny tiny square last time. This time we have a rectangle. If you want, we can draw our lines here. I know it's not perfect. It's kind of hard to draw with the computer, but we can see that we have our rectangle. Well, before we can find the area and perimeter, two methods. You have a graph here, you have all these grids. So you could technically just count up all the squares inside to find the area, because that's what the area is how much is on the inside. But since this is a bigger shape, it might be a little annoying to have to count all those squares. So let's just find the distance so we can identify our length and our width. So right here, it looks like we're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have a length of 12. I'm going to double check that to make sure I didn't miscount. So if we look at our green and our purple points, these are the ones that I chose. So U and X. We have 10 and -2. We take the absolute value of that, giving us 10 and +2, which would be 12. Perfect. My length is correct. Now for our width, we come down here. It's 1, 2, 3, 4, 5, I believe. So if we double check, I decided to use the green and the blue points. So U and V, these two right here. The X's are the same, the Y's are different. We have -5 and -10. We'd need to take the absolute value of both points, 5 and 10. When we find that difference there, we get 5 units. So this one is a little different since we had to find the absolute value of both. That's why we needed to subtract instead of add, where when you only have one negative and you have to find the absolute value of just the one, you would add. So it's kind of nice we had our graph there to help, reassure us since that one was a little different. All right, for area, that's our first question. The formula for area is we take our length times our width. So in this case, we have a length of 12. Oops, I forgot to change colors. And then we'll multiply that by our width of 5. 12 times 5 is 60 units squared. And that would be our answer. And I put an S instead of a 2. Mrs. Elstock clearly needs to get some lunch here. Her brain's not working right. So if you guys haven't had any of your lunch yet, make sure you get some food before you take your quiz. That'll help you think better if you're not focused on your tummy. All right, second question is we want to find the perimeter. So once again, if you wanted to, you could continue to count all the way around because perimeter is like a fence, it's the outside, and you could get the answer. Or since this is a bigger shape, we can use our perimeter formula. And our perimeter formula is we take 2 times the length because we have 2 lengths, the top and the bottom. And then we add that times 2 times the width because we have 2 sides, left and right. For this problem, we have a length of 12 and a width of 5. I forgot to put the 5 in. I put the W. We know that the width is 5, so it no longer needs to be a variable. Order of operations, we'd multiply before we add. 2 times 12 is 24. 5 times 2 is 10. We get a perimeter of 34 units. Perfect. All right, guys, I know I covered this in class, but just in case you missed it, things are a little glitchy. Here is what you guys now have to work on for today. Please make sure that the IXL assignment, which was assigned on Tuesday of VHQ, that's graphing ordered pairs, make sure you work on that. I decided not to give you guys a second exit ticket because that exit ticket from Tuesday went over reflections and we covered that today. So, little gift for you. You just have this one exit ticket. So if you haven't done that yet, the 602A one, make sure you go in and complete that. And then the quiz that you have available is the 602 quiz. When class ended, I changed it so there was only one attempt because I didn't want you guys to use both attempts before this video came out. So now that you've watched this video, you will have your traditional 2 attempts on that quiz. So please go ahead and either take it for the first time or retake it, and hopefully you'll be able to show that you understand this. And if not, reach out for help, rewatch the video, or of course, we'll have our help session next week as normal. All right. Bye, guys. Have a wonderful weekend. See ya.